I wanted to talk a little bit about intelligent systems and the evolution of IoT. But always, whenever you start off a talk like this, you like to start talking about IoT because, IoT sort of as a trend. I think it's surprising everyone in the industry because every slide that you'll see has these huge numbers on them. And really, what's happened is for a long time, it's all about the flat line down here. And more devices are showing up, but very little of the magic that was promised in IoT has yet to be realized. What we're seeing is that we think we're coming close to an inflection point where you're going to see some of that. And the measurement for us about what some of that means is that you'll start to see early mainstream adopters. And if I were just to characterize the first long flat section there, we had a number of people, some people would call them early adopters, I would call them tinkerers, who wanted to participate. They had a set of devices and really went with a promise. And that's been a lot of what's happening. And coming into this, one of the things that I want to talk a little bit about is what's starting to cause it to change and how are intelligent systems playing a big role in that. So with that, I thought I'd start with a little bit of an introduction of where SmartThings started. SmartThings started as a Kickstarter campaign 4 years ago. And it started as a really very simple premise. And the simple premise is that you had a few of these devices. You'd like to be able to connect them to a cloud in an open way. And we invented the concept of a smart app. And a smart app is really an agent. So it can do simple things. So one of the most simple things is if there's motion, I could turn on a light. Two of our most famous sort of initial smart apps were a little bit more sophisticated than this. So one of them looked at the weather forecast and said, if there's rain in the forecast, I'll delay your sprinklers for a period of time. Another one was vacation lighting, where it would learn the behavior that you had with your lights, and when you were away, play back something that was close to that. And all this went along pretty well in terms of solving a couple of simple use cases and really having what I would call early intelligence. The challenge is, and actually you can't really see it very well on the slide, so I'm going to have to explain it, is that as you added things like Nest learning thermometers and a number of other devices started to get a little bit more intelligent on their own, and all of this came together, you got something that resembled a lot like a traffic jam. And it was just because as devices were increasing, and each of them got paired with a little bit of intelligence, it's hard to call it a large amount of intelligence, there were some immediate conflicts. One of my favorite ones happens with the Nest thermostat, where it's trying to learn whether it's away. And so you'll have someone who'll go away on a business trip unexpectedly. The thermometer's testing the hypothesis that it's away, and your house looks like Amityville Horrors, and it's flashing its lights because it's going from the away state to the home state and back to the away state. And the other learning system is learning in response to the sort of slightly deceptive signals that it's getting. And so this is one of the things where SmartThings has sort of now tried to move from that early stage of a couple of independent intelligent agents, which we've called smart apps, to this next level of intelligence. And I'm going to take a small step back there and say, as we've learned some things too that we didn't do exactly the best way as we started. So one of the things that we did in talking about security from a previous panelist had sort of mentioned that often you approach things naively when you start, and that's what we did. The way that our smart apps work is that they're really a hosted execution environment in the cloud. So you write a little program, it sits up in the cloud, and it's, of course, executing in a trust-based model. Now, we put the user in front of that, and so you have certain capabilities. So you would say, for a particular smart app, I'm going to permission you to see sets of devices, maybe the motion, maybe the lights. We tried to make it a little bit easier with things like locks, where we'd say, well, there's a couple of highly secure devices that we might prompt you differently about. But overall, it was a pretty coarse-grained permission model, and because the code was executing in a sandbox in the cloud, there are privileged escapes and all of the other problems that could be associated with that. What we're doing is to move beyond this and to get to a model where it's a little bit more composable and scalable. we're moving to an untrusted execution model. And so what happens is you could then execute on Google's cloud, on Amazon's cloud, on your laptop. In order to power that, we have sets of one-time keys and special capabilities and a number of highly technical things that sort of enable moving from one to the other. But this is a natural part of the evolution, is that we see that implicit in sort of intelligent systems evolving, and I'm going to talk a little bit about how intelligent systems have to talk to each other, there's also the security aspect, which is equally important, and you start to have to manage trust and trust between those systems. One of the sort of natural things to say is, well, we haven't really noticed that adoption has been super fast in IoT. And that's right. Actually, customers have had 2 or 3 key problems to date. So one of them is that scenarios haven't really been super compelling or super achievable. And why I'd say that is, an example is just to set up your very first device, you'll generally have to download an application. After you download the application, you go through some kind of a login process to a cloud that you may or may not visit again. After that, you'll have a device which has this antiquated notion called pairing, which you'll then start to go through. All of these are largely fail-prone procedures, and they sort of get you to a point that maybe if you did all of that right, you have some interaction. The other kind of problem that happened with that is often, just like home automation systems, and I'd like people to raise their hand if you could program your own sprinkler. That's what I thought. Oh, wow. Actually, there are some people here who can. I can't. And you end up having to do this huge upfront cost for something you may or may not use. And that's kind of the structure. And it's partially because IoT sort of patterned itself off of the fairly, I would say, unsuccessful industry of home automation, in that mainstream people really never quite were able to figure out how to do some of the things in home automation. So there's a lot of this friction, and a lot of it where you'd sort of do it up front. Let me describe what a better scenario or a better way to be introduced to some of these things, and this is sort of where some of the intelligent systems are coming in. You leave your home, your cell phone says, hey, your TV's on. Would you like to turn it off? Would you like to keep doing that? This is another way to introduce routines that's much more natural. Couple things that happened in that interaction is I didn't have to download an app to my cell phone to have this happen. And I'll talk about how you could actually achieve this kind of magic, because it sounds like magic, in a few seconds. But first say that the difference to the user is substantial. It requires a different set of systems because you need to be able to advertise these capabilities. You need to have the user be able to accept these capabilities. But there are some pretty natural ways to do things like that. One of the examples is maybe you're quite happy to have all the appliances in your house advertise capabilities to you. And that's where we have a Works with SmartThings program that allows you to do that and sort of accept it in that way. All on this idea of saying, hey, I'm really offering an opportunity when it's actionable to you, rather than having you imagine whether you might want to automate, your washer, your dryer, your television. Those things are difficult. The other part of it is educating people what's possible. This is why it's so important to tell them about something when it's actionable. It's very similar when you're on an Amazon website and you'd go and they give you an offer to sign up for a credit card right when they can offer you $10 off because it's the last step in the purchase pipeline and you're just about to buy something. So they're pretty darn sure that that's a really good time to talk to you about a potential rebate or bundle in some other offer. In the same way, if we're looking at incentives for IoT and getting people to move forward, we really want to talk to them in that case. So, oh, you already had a problem, the TV was on and you didn't want it on while you were out. And that's a time to sort of build in a lot of the questions. Because one of the challenges in IoT is despite we can do a lot of things automatically, at some level you have to involve the user. I mean, it's their home, or if it's in the workplace, their workplace. But it is, you're really in many ways impinging upon them. And so you have to involve them. You just want to make sure that you're going to do that. The last kind of large-scale trend in terms of customers themselves is that I could invest a whole bunch in my home and put 50, 100 devices and do a bunch of automation, and there wasn't natural ways to share. And if we look at a lot of the successful services, they have natural ways to share and benefit from expert users. Just use music as an example. Custom curated playlists from a set of users who spend a lot of time building those things. Most users don't ever create a playlist. And so this is one of the other challenges in IoT, is that there are some people who are willing, for the glory of it, I'll call it, to create really advanced setups, really special interactions, but there's no good way to share it, and they're stuck bespoke. So this is a number of the sort of drags. Addition to that, there's been some systematic things that I wanted to talk about. The first one, which should have been obvious, but actually often wasn't because people are so excited about moving to IoT, is that dumb solutions are actually really good. Light switch, 30 milliseconds till everything in the room turns on and off. That's pretty darn fast, and it's really secure. And so because of those things, as we look at some of the digital solutions, a lot of them would be one step forward and two steps backward. And similarly, most of the buying cycle for things that are both in the home and industrial contexts, they're usually a buy when it breaks model. And it's really hard to get people to do things early without the emergence of some kind of a trend. And I'll give you an example of one such trend is Airbnb, where for the longest time, locks, it was really difficult to get homes to get any type of electronic or IoT lock. But now when people all of a sudden want to rent out their house and they say, I don't really want you to have this key that you could duplicate, and I would like to have a very secure way for me to manage that, all of a sudden that's driving buying behavior in locks because people had a real incentive to do it. And so that's sort of one of the challenges. Another one that's systematic, that's been under consistent pressure for the last few years and seems to finally be breaking some of the magic points, is cost. And where we're seeing it now, you can get kind of a starter IoT solution for around $99. That starts to get in the point where cost isn't a barrier. But what people didn't see for a really long time is that you had these setups that someone might spend $20,000 to $50,000 for, and that you could do it for $2,000 or $3,000 was just not enough for your average homeowner. And so all of that was putting this weight. And coming out of that weight, you had people hooking some stuff to the cloud. They do something exciting in one area or another. That an area might be in something like an Amazon Alexa, which is showing up in voice, and people kind of say it's pretty cool that I can turn on my lights with voice. But every one of those was independent. And so at Samsung alone, we had 61 different applications on mobile devices to control the, I don't know, call it 2,000 or 3,000 Samsung devices that existed, and over 200 clouds. So we made a company initiative that we are going to have a single cloud next year for all these devices. We'll be actually announcing it at CES. And by 2020, any two devices that are Samsung devices will be able to pairwise communicate. And so that's sort of something that we've announced and are really pushing for that level of simplicity. But even within a company, to get that level of defragmentation is not really doing something beyond it. And so you end up having all of these clouds, each one of them pretending it's slightly intelligent. And then you had the user. And on the user side of it, this is something where we have to start thinking about our users differently. In the early days, as I pointed out, those users who I decided to characterize as tinkerers, 1/3 of them actually downloaded an IDE. That's something that obviously is never going to happen for the mainstream developers. In most cases, they were just copy-pasting or following a recipe that they had on the internet to get to a more customized, a more interesting solution. The other thing that happened is that a lot of the interactions we started to have were cloud to cloud. So we'd have Alexa, Sonos, and Nest. Every one of those is a set of pairwise user interface where, example is, if I'm adding a Sonos speaker, I have to go log into the Sonos system. As a user, I'm sent through a set of pages. It's a lot of work. It works when there's maybe only 5 to 8 things that you care about. It's certainly not going to work over time. And so we end up having this situation where it was a little bit too easy to involve users to solve these problems. the way that these problems were surfaced to the user was not that great. And a lot of the onus for security was placed on the user, who had often a poor understanding of kind of cause and effect. So like I talked about with the Amityville lighting, as people added devices and use cases, unexpected actions were growing proportional to actually the square of the number of devices that you had, which was not a great impact. And then worst of all, this started to become not self-healing. So this is where I want to, I'm going to sort of bridge the talk and to talk a little bit about how these intelligent systems are going to talk to each other, but I want to talk a little bit about the outcome, where not only do they help in terms of possibly bringing more intelligence into the system, but it actually changes the way adoption's happening in IoT. So I wanted to give a simplified model of adoption and then talk about what the role of intelligence is in attacking that. So in traditional models for adoption have 4 basic roles, and there are more sophisticated models that build on this. But in general, you have the potential person who could adopt it, and you have this great state when they get from potential to adopter. And then there's 2 other roles in the system, which in early models they thought of as people, but later on they figure out that that's not quite the case, is that technology and other things can take them. So you have a change agent, which is someone who's able to help you go from that potential all the way across the chasm. And then at the same time, in theory, in the old model, you'd have this disruptor who is acting in the same way as sort of an advocate for either another system or certainly against your system. And the thing that intelligence can do is that if you looked at the way that these things are segmented, they're often like a step function. And your potential market is governed by a lot of different things. Some of them would be, an example would be if I have lighting, how likely am I to move to the next use case? So for SmartThings, what we've noticed is, as an example, is someone who starts off with about 5 devices, within 90 days will go to 12 devices. And it's this nice cycle where they start doing stuff, and they're like, oh, that's kind of cool, maybe I'll do a few more things. And it's pretty common for you to go, for example, from lighting scenarios to monitoring scenarios, or from monitoring to lighting. Don't tend to make the jump to security because it's actually a little bit different. But you tend to stick in these spaces. And this is where the interesting thing about intelligence is, as you start prompting in the ways that I was describing, that are situationally, you can turn this into a bit of a continuous function. And so as we are able to catch the person in the moment, or we can look at some of these patterns, what we've seen is we can talk to people. We know what the right time is to start talking to people about an energy solution. We can talk to them about something like, hey, would you like to see who's at your front door? And what that does is that changes the potential market in terms of its granularity, and turns it more into a continuous function. And this is really, really important for the adoption, because a lot of the adoption was having trouble crossing this chasm to get to this point where you have a large set of people who can adopt, are interested in it. And what we've seen sort of happen because of this, a good example is voice. Voice was really interesting to a lot of people, and now you're seeing a whole bunch of people adopt IoT simply because they can control things through voice. And it bidirectionally helps. So if I use the Alexa example, if you have SmartThings and you have Alexa, you do 60% more utterances in your first 2 weeks, and you're more likely to do you are likely to do about 4 times as many user activities in the first month. And it's this thing where you were doing things that were kind of meaningful to you, like turning on and off the light, which is sort of more meaningful than maybe playing music or some of the entertainment scenarios, and you start to build a little bit of a flywheel. So this is where, as intelligent systems kind of work together, there's an opportunity both to turn that adoption function into something that's more continuous, but also increase the value, increase engagement over time, some of the other things that really help people get over using it. One of the earlier speakers today talked about, if you often look at what we call D90, which would be what happens after 90 days, or D180, what happens after 180 days with your service, if you don't get some of that stickiness, you can find 25, 50, 75% of your population will drop off and are not really interested to continue. So that's one side of it where we sit there and say the intelligent systems allow us to attack a lot of the problems that have impeded adoption. The other thing that they're really helping with is that event data has been a challenge in IoT. And part of the reason for this is that IoT often had or went from the home automation where you had an admin or an installer. And in lieu of that admin or installer is the first person who sort of put the solution into your home. And the challenge in there is that there are a lot of adverse things that can sort of impact that installer. Some of them are detected by devices, others aren't, but examples of those would be daylight savings time, I'm away, all of these types of things. And they require us to kind of anticipate problems in the data streams, and that both impacts the structure of the data itself, but to some extent, understanding, being able to walk back on the outcome that you're using that data to understand what that work process was that yielded that and what problems can happen. So examples can be, what I should do in the case I failed to arm. And you can just go across the events, but say that it wasn't enough to just look at the data itself. The other trend is a lot of the data that's produced by a lot of these devices is unstructured, and you'd want a little bit more structure to them. Video is one of the best examples for this, where you like things like the number of packages that show up in the door, number of people in a room is a structured event that you can build a rule around that you can actually do something smart with. And so this is where these are also pushing intelligent systems, because you'd like to have, we, for example, employ recognizers that recognize people and packages today. We'll probably extend that to a bunch of other interesting recognizers. But in general, this is where the event data itself is, if it was okay in its unstructured form and you could just analyze it all in the cloud, you'd be fine. The other challenge is a lot of the patterns that are starting to be interesting in IoT are the second level patterns. So you'd like to know, when were the cleaners done? And there's a lot of ways that you can sort of, in general, sort of teach, learn, and then evaluate. But finding these patterns has also been really pushing intelligent systems, instead of sort of saying, well, I'm going to do this through a calendar item or something else. The last piece of it has been really a bunch of non-traditional data sources are now coming into IoT and actually turning out to be really meaningful. One of the ones that's starting to be pretty common is for a cell phone to be able to broadcast the fingerprint event. And that can give you one factor in the authentication. And then we might use something like a network join event of your phone as a second factor, and then we'll undo a lock. Or calendar events and motion data from your phone. Did you really leave the office when you said? Was traffic heavy? Might start to increase the water heater, adjust your house to some of the things that you wanted to know. We've experimented a lot with data from Facebook and Twitter, which interestingly enough actually can help with these rules, but lots of these non-traditional data sources. And again, to manage that and understand the patterns, it's really pushing into these intelligent systems. So what this has done is sort of now gotten us to try to integrate these systems together. What I'm going to call second generation intelligent systems are these systems where we've tried to integrate together towards an outcome. So I'm going to give you a couple of examples. So one of them, we worked with Amazon about a year ago to do this and launched it around September of this year, where we did what we called domain voice integrations. But the basic idea would, you'd say, Alexa, good morning, and that's a shorthand for Alexa, ask SmartThings to execute the good morning routine, which would cause a whole bunch of things to happen potentially in your house. And the way that they're able to do that is that we give them a set of routine names and common things that would be similar to those routine names to sort of index into their system and understand the voice elements of those things. And then we work with them to be able to have some kind of a ranking system that would say, how likely was it that when you said, Alexa, good morning, that you actually meant this to happen? One of the unsolved problems that we didn't do is, well, what if several people wanted to do something in response to good morning? The way we worked with them was just to pick the best. Kind of like when you say, Alexa, play the Beatles, it'll say, well, I might have several music services that could do this. I'm going to pick the best one. In that case, it's kind of okay that you had this situation where you simply picked the best provider and then hopefully did the right thing. It doesn't work across some of these broadcast events, and that's the next problem that we're working on. But it's an example of these type of second generation systems where we can go into a domain, there is more intelligence. The user's way happier with Alexa Good Morning than they were with the archaic tongue twister that I was trying to say before, which I can't even say on a good day. But while it addressed some of the things I talked about, where we can sit there and say it aids a bit in the transition of early adopter to mainstream, and changes the effort a little bit that's required to be done, it's still all in all pretty clunky. And for a lot of IoT, it's taken us a little bit of the way, but not that much. The other thing that's happening at the same time that's also kind of trying to address this space is chatbots. And part of that comes with mobile applications have just, they're creaking under their own weight in terms of the UI complexities. Every time you add a new concept, you have to jury-rig it somewhere in the UI into this existing expanding thing, and then it's really hard for people to find anything. So the basic idea was, and has been, that for a lot of things, when you have a sparse space like that, especially true in IoT, where you have these devices that will have a myriad of capabilities that you rarely use, and so then this chat-like interface tends to work really well. And so that's where, again, this segmentation where we can have intelligent systems that handle a particular domain, like say heating, and provide you with the commands. That's been a set of nice integrations. And then there's other people who provide the natural language pieces, and we can sort of go through that domain where there's a couple of systems kind of working together towards a goal, but it's not really, really having the systems work together in a deep way. Where we've started to talk about things and haven't quite got to them is a number of sort of commercial situations that build on that, where you really have kind of a more complete solution for a person. And an example of some of these things would be in security. You want to enable responders to be able to look inside your house if there's a fire. Now, of course, you'd only want to do that if your fire detector went off, because if they tried to look inside your house and the fire detector didn't go off, and there's no real reason for the fire department to be looking inside your house, that would be, a violation of privacy. And so, as we start to layer in a scenario like that, where you as a user can give a class of people like responders a set of capabilities and put some natural conditions around those, that's more of these types of second generation situations. What's exciting for a lot of people in the IoT space, especially the companies that are involved, is it actually often can help them change their brand. So one of the great examples for this would be somewhere like home insurance, where right now, they really just help you financially recover from a disaster. But we talk to them, hey, the two, most impactful things for the size and cost of the settlement, it's usually a fire or flood, and those ones are, often may take them more than 20 years of your premium to solve, often much more than that. But if they can catch them in 3 hours, basically C6 and 12 are sort of these magic numbers, they can dramatically reduce those things. And so we say, oh, well, what if we have a way that allows a professional installer via your home insurance to install flood detection or upgrade your fire protection? They can pass on some of those savings to the consumer in terms of premium discounts, but it also allows that consumer to sort of get up to this next level. But you would only do that in cases where you sit there and go, again, you're sort of permissioning in this way, where I'm going to sit there and say, I'm going to allow you to monitor some set of compliance around the things that I'm doing, share that data in a way that can allow you to sort of actuarially get to a better outcome, but not necessarily let you hold on to that data forever. That's sort of a reasonably positive interaction that can be had from the consumer's perspective. From the insurer's perspective, they're really excited because they all of a sudden got into the prevention business. It totally changed their brand. And so it was this interesting where an intelligent system can enable someone to look at a problem differently than they were and a new set of people to participate. And that's a lot of the excitement at sort of bringing these things together. Which sort of says, well, you know, what are we sort of, where are we and where are we moving to? And kind of the situation is here now, because a lot of these integrations between what I'm going to use air quotes, intelligent systems, have looked more like this picture and not like this picture, because we don't have a lot of the right primitives. And that's sort of where I'm going to start to get to, is that, you know, some of the things that are really difficult is you want to actually enable the systems to work together towards a clear goal. We want to be able to evolve objectives. Some of the primitives that you talk about to do things like that is like, I want to express expectation. I want to be able to communicate intent. I want to be able to communicate things that I'm worried about. And so, you know, in there, if we look at a shared goal, that's, you know, one aspect where it's really helpful to have a set of devices contributing in a particular way, in a formal way. We have natural primitives that we've used sort of in the research in multi-agent systems have looked at this, but there's a lot of things in distributed systems that already do things like this, like leader elections, specified roles. There is a corpus of knowledge that's mostly used internally when one system is sort of, if I look at how I deploy, for example, our systems in IoT, in AWS, we have a number of distributed systems. They can discover each other. They can, you know, adopt a lot of these herd mentality objectives, but none of this translates between our systems. So when Google and our system work together, we don't do this. And so as a result, collaboratively sensing and responding change or identifying opportunities, even simple things like saying, here's a set of devices that didn't actually get the message about the fact that daylight savings times happen, and these are the ones that did. And I can tell that very obviously because their timestamps are all off by 1 hour. And then maybe be able to work with the system and the cloud that they're part of to address that. And you know, one of the biggest challenges in IoT is why all this is important is that usually you deploy a system and new challenges happen. So it wasn't necessarily something you thought of when people started doing that. And you know, one of the best examples that I seem to be using far too much, and to stop that, is daylight savings time, where it's actually changed over time, and different states have opted in and out. And you know, overall, it's hard to have anticipated all the things that happened. And so it's mainly because you have this sort of problem where a system will start with a set of rules, a set of desired responses, and if that was in isolation and it all ended there, we'd be happy and we really wouldn't need these systems to work together. But that isn't the world that we live in, and that sort of isn't where IoT is. So what's a framework for the future? And what's happened is there are a number of standards bodies that really try to focus on, and this is sort of operated over the past 5 years. OCF is one, but there are many that really try to define the entities, the resources, the capabilities that they have, the relationships. This would be things like location, how do devices talk to each other. A lot of that has been ironed out, not completely, because actually, as you heard from previous speakers, there's still a lot of opportunity. But overall, that area is more mature. What's much less mature is, you know, if we look at some new primitives where you could communicate intent. So, for example, I'm the Nest Learning Thermometer. I'm telling you I'm trying to test a hypothesis. I'm testing the away hypothesis now. I'm somewhat sure that the away hypothesis is true, so now you can start to take action on that. Expectation, promise, some of the things around calibration, failure avoidance. These are a new set of primitives. You don't need too many of them for the systems to talk about, and you can get some pretty good outcomes. In existing integrations, the ones that I previously called second generation, mostly we actually look at just a couple things we inherited from distributed systems. So we hold each other accountable for availability of the service. We hold each other accountable for response times on a few APIs. Basically said, hello, you're there, great. That's the level to which we work together. One of the other challenges is we believe strongly in open as an approach at Samsung and SmartThings, and try to use open standards uniformly for things that we're doing. Google and Apple aren't as committed there, and that's sort of runs into its own set of challenges. So again, with the Nest thermometer, I now have to be a human being to change the temperature. I actually can't have a smart app do that because the data regulations or the data usage policy of Nest prohibits that, prohibits automation, because in theory it's learning all by itself. But the implication of its learning all by itself is it now has to be aware of every single event that happens in the universe. Like, that's the model. The model would be, you'll have to learn about arm events and disarm events. Because normally I would say, okay, well, once you did an arm event and alarm system, then you should know to go away. And I could have told you that if you would allow my system to program you and tell you that it's away. But since you won't let me do that, you now have to know about everything that I have to know about, which is it's the human side of the challenge in terms of having these intelligent systems work together. Luckily, a lot of the cloud companies are really interested in doing this. So one of the examples is Uber. Uber wants to hook up with everyone, tell you when your Uber is like 5 minutes away, when it's 1 minute away, oh, your Uber's there. And they're actually much happier to say, as long as the customer permissioned you at a system level and saying, allow my devices to know about when my Uber is coming, they're like, we're happy to give you the data. So it's a situation where companies are approaching this differently. I think consumers have a role to kind of push people towards a more open approach. But overall, there's a lot of opportunity for thought in terms of helping companies go past this, make this evolution more natural. Because they've had so much success in some ways with the single list system integrations that we've had for a set of problems that works very, very well. But then there's a lot of things where it doesn't work as well, and that's where it needs a little bit more of a nudge. The other challenge that comes into this is that what we've really noticed is as all these systems start to update, and each one of them has several components, so you might have the Nest thermometer and it has its firmware, it has its cloud software, all of those are kind of updating. And you don't have this transactional integrity of going from like one good state to another. So what happens is that usually in there, say the firmware is updated, and it can be differ by customer. So for customer A, my firmware is updated, I have cloud version like 17.4 on Google. On the SmartThings Samsung side, I have cloud version B, and we then have this sort of explosion of use cases. So we have to handle, what happened if that customer was in the group, because one of the other problems with clouds is it's not uniform. Most people use an approach like we do, where there's a web lab and you're sort of enrolled in a particular treatment. And so we have to know about all the treatments that you might have. That just is this huge explosion. And in general, this means that we need some better primitives to allow people to sort of go from known good state A to known good state B at a population level. And that will require these intelligent systems to talk more to each other. Oh, I'm testing experimental treatments, so maybe I should stick to what's known on this side, and keep the variables out of the system. But overall, there's a set of problems that aren't well solved today by these intelligent systems operating independently. One of the biggest problems, and I've described a few flavors of this, is optimizing cost problems that spans providers, or satisfying constraints that span providers. And those things mostly just fall on the floor for one of two reasons. Either we didn't actually create the optimization that worked across them, or it started to work for a period of time, new things happened, and it broke. Just give one sort of concrete example in this area that's pretty common in homes now is people are starting to buy with Netgear some of these cameras. Most of these cameras have an arm state. Of course, you go into that arm state just by using the mobile app. When you arm your security system, what will happen is it will not let you succeed at arming your house unless it went through each of the doors and armed them. But since it has a fire and forget model for the cameras, they may be armed. And if they didn't succeed, then it doesn't do the same type of behavior of rolling back the arming based on something failing, which actually is the reason why they always have to brand these solutions as monitoring rather than security, because in security you'd be violating state regulations if you didn't allow it to do that. The other thing that you have to allow people to do in that case, which is similar, is allow a customer to say, oh, it's okay if you don't arm that window. As long as I, the customer, told you that it was okay to skip that device, you can skip it. And these are examples of things that just get really hard when you start to have these independent clouds talking to each other in limited ways, usually because all of us kind of operate on our own copy of the data, which in general, in theory, most of that data is similar. At least you'd sit there and say, you know, an example for this is Nest has shared a bunch of data with us. We've shared some other data with Nest in terms of the sensors sort of talking to each other, but we don't really get that. We don't really get to that integrated execution. The last piece, which is really important, is that this is part of addressing the IoT problem that I really talked about at the beginning, where the offline solutions or the quote-unquote dumb solutions are so powerful, is let's then talk about adversity, like when your hub goes offline so you can't communicate, or the power goes out, or you have differing levels of connectivity. You know, in some cases, we have some security devices that can fall back to 3G or a cellular network, and you'd like to make use of that in other places. And so a lot of these things start to really push towards these intelligent systems, talking together with a few primitives. An example of a primitive there that would really help is I have some critical information I need to communicate, and I would just say, use the best channel for that. This is some information that should always be communicated. It's a heartbeat or something of that sort. So those problems have sort of taken us to a situation where we can move to these primitives where we get the team-like organization. You want the coordination, you want the knowledge transfer, you want the roles. One of the biggest problems, though, is that this is going to be much more of an n-squared issue than the devices one. And so what we don't want to do is follow the existing pattern where we exported system negotiation to the customer. And you'd say, well, of course, that's self-evident. While it's self-evident, actually, that's exactly what happened in the second generation solutions. So self-evident that you wouldn't want to do this and it wouldn't scale, but that didn't stop it from emerging. So, you know, this is if I looked at the next 2 years in IoT, a lot of what it's going to be is starting to standardize some of these interactions across these clouds that are working together in common ways. And give people ways to sort of extend pieces of it, like classification is an example of this, where example for us in video is that we support 2 classifiers. We want to be able to support a number of others. And what this gives you is natural ways to inject your functionality into another system for the benefit of the customer. In order to do this well, we think an open system works really well. It also gives the right level of incrementality, which will allow this to be adopted and move forward. In general, and this didn't work out so well, the font obviously, all of this powers what is the virtuous cycle in IoT. So the virtuous cycle sort of starts with some devices which will generate some data. That data will power a set of use cases, which actually, as you have interplay with that data, it sort of generates new events and new data. An example for that is you can have a motion detector and you have a light, and you then start having motion powering the light, and in that composite, that allows you to build sort of magic out of the constituent parts. And what you're then trying to do is that generates a bit of engagement, which causes you to add some more lights or do something different. And so this is where intelligence can really allow people to start doing, more data, more use cases, more devices, more possibility to add more devices, which will do more, and it just keeps going. And a lot of that is powered by these intelligent systems and having them work together more closely. So with that, I wanted to thank everyone and potentially take questions if I went 3 minutes over to take some questions.
So with a lot of the apps and the value of ads and things like that came on over the last 10 years, we got used to getting services free that we had paid for in the past. So as our things get smarter, are we going to get a free smart fridge in our kitchen because it's putting out valuable data to somebody somewhere else down the line? Or how does Samsung view that?
Yeah, absolutely. It's a great question, actually, because everyone's always asking what the monetization path for IoT is, and there are a whole bunch of people who have very different ideas. I think that there's not going to be any one single path, but there are a couple of paths that I think will make it very adoptable. And the paths that focus on existing economic exchanges that you're already doing, whether it's home insurance or it's your Comcast or a number of service providers that you're already dealing with, and the opportunity to use that data in those ways, I think will enable a number of people to adopt much more easily than they would otherwise. In terms of the value of the data, sort of if you go to the Facebook side of this, we're saying you are the product. The data about everything that's happened in your house for the past 2 years, that's got to be more valuable than everything I typed into Facebook. That would be sort of one of the things that I believe. So I think the danger there is much more how people will learn to be able to manage that. For good, I'll give you examples of some good cases where, hey, there's a billion-dollar startup called House, and they do home improvement stuff, and they have about 35 million members. But since you don't do those transactions very often, it's really hard to recommend anything. And it would be great for them to be able to license a data source. I think the best model for that is sort of a YouTube-like model where as a customer, you'd say, I'm going to give you some money for that. So I'll sit there and say, you certainly can permission House to get access to your data for which they're going to pay some rate. You should get turn you into the App Store provider where you're sitting there going, you get your 30% rate on that. And then I think that a model like that really aligns incentives across the system. As a customer, you feel like, wow, actually, that might be money I could go spend and make my home even smarter or do something else with it. But then I'm getting some value out of the data. And I think that given that this data will be super valuable, so standard sort of social data and eyeballs, this is the other side to it, is if you look at a regular application today, maybe something like Facebook, 1 out of 3 days you'll go to on average or something like that. That would be about the level of engagement that they have. For us, 90% of our users come back daily. There's a reason for that, because you probably care about stuff like when your door opened and door closed and all of these things. I mean, it's something like, it'd be kind of like saying, how long can you stay in your home without leaving? But in that, then your value to advertisers is much, much, much higher. And so because of that, then we also think that not only was the data valuable intrinsically in the way that I argued, but the eyeball is also super valuable. So with this, I think that it's really incumbent on IoT to really look at making sure that users participate. And if they do, I think it'll be good. If they don't, I think they'll look to policy measures to protect them.
First off, I learned to do the sprinkler only because I live in California. Drought. So they penalize you if you don't. So when you're talking about
I let my plants die instead.
When you talk about the security, the crypto locking keys, and things like that, as we move towards interoperability, how do I expose myself to the existing smart home network that's there so that I can authenticate myself in and share in that?
So I have an opinion on this. It's not proven, because one of the challenges with the cloud is people can make an end run around anything that you do. What we've done is we have a hub. That hub has a very secure set of transmission to the cloud, and we try to encourage you to connect even IP-connected devices to go through that. So you might have something like a Sonos, which can actually independently talk to the cloud, but we say, well, I don't know that you want to do that. Here's a better way. I think these gateways will be formalized in terms of their role. I think there'll be a lot of incentives for people to start to adopt stuff that looks like this. But I think the natural thing is do you want to have a house that is unlocked all the time and all the windows are open, or do you want to have something that you sit there and say, yes, I actually bothered to put a lock on most of my doors? And so that's what I think will have to happen to customers. Right now, though, customers are not really choosing to adopt because of security. We did a bunch of customer research on this, and it was really interesting. Price so dominates customers over security, and it's partially because they're not quite sure what that bad outcome is. And it's probably going to be a situation that's similar to car insurance, where you sit there and go, no, for the sake of the population, I'm going to have to force you to do something, because you're optimizing for a different set of considerations. But I think that those things will change, and I think that the right model is to have designated roles like gateway and enforce it that way.
I recently sold a house that had quite a few IoT devices in it, and the process of turning the access over to the new owner was completely useless and dysfunctional and was quite
Impossible.
for both of us.
Yeah.
So I'm hoping somebody's working on a solution to that problem.
So again, I think that the way that we look at that is that we have this idea using Samsung has a Knox technology that we use in the cell phones, where you can basically back up your home into the cloud. Same way that you'd sort of have, it's relatively painless for you if you lose or smash your cell phone, provided you've been backing it up to the cloud, to get a new one. And so we kind of have a way to do that. The problem is, embedded in the standards are some things that make a lot of those steps manual. And that's really, like, even if we had the key and we could send back down the key that that device is supposed to be using, it'll say, oh, in order to do this and for me to assume the exact role I was doing before, I have to go through into this pair replacement thing, line 74 in the manual. And so I think that one of the key opportunities is to sit there and go, okay, there's going to be all these devices that look like that, but we're going to offer new devices that support both kind of the backup performance, and it would be kind of like the difference between kind of a RIM phone and a smartphone. Back in the day, you had a number of things that weren't as good. But that scenario is starting to be a huge problem, even if you don't sell your home. So that device breaks. And there's a whole bunch of these other scenarios like that. And it wasn't thought through because the basic idea, I think the premise that unfortunately we stole a bunch of these devices from the automation space. They had an installer. Those installers came in one time, and it set a whole behavior pattern in an industry that made it really challenging.
It's particularly hard when you turn your cable modem in,
Yeah.
and then the new owner shows up, and there's no way to even demonstrate any of the functionality for them, much less how you log in or any of those things.
Actually, there's two embedded problems there that are kind of interesting. So embedded problem number one is most of these things require the cloud connection. Even if you thought, even in the home builder case, you'd say, I'd want to pair all the devices, get the whole thing done in kind of an offline or locally collected mode, and have someone come by and claim it, kind of like you claimed the device to begin with. So that whole workflow is kind of backwards. And then the other part that's really interesting is that if we look at sort of the fragility of the system from a customer perspective, they have no idea what to do, and if something goes wrong. So one of the things that's amazing is this actually even happens in the commercial setting. So right now we're renting out our office in Palo Alto to Cisco, and I know that one of the other speakers was from Cisco, so he may be ending up there. But we actually have to keep our network on until Cisco has come, because the card readers at the door, like all of this stuff won't work. And we have all these things where we actually have to segment that away from the network. We have to put in a bunch of special firewalls just to actually make that happen, because no one in Palo Alto had a plan for how you would do exactly what you're talking about. And Comcast said the same thing. Like they said, absolutely, like don't do anything till they've moved in. We're going to send in a transition team. I don't know if it's going to work, but it really happens in industrial space as well.